of saying everybody to get in the plane has to have a mask on. If they don't have a mask on, then they can't get in the plane. What are we doing? Do you feel comfortable being in a, being attendant and people getting on a crowded plane or not a crowded plane with no mask?
Yes, I do feel comfortable going on a crowded plane without a mask. That's called normal. That's called everything normal up until 6 months ago, Joe.
I'm
not scared of humans.
Who have been caught in the lurch. Look, the president, and he should.
Thank you for doing that.
And I have to do it anonymously because I don't know if, I'm sure you know, I'm sure some of your listeners know.
Mm-hmm.
In years previous to this, there's been many doctor deaths. There's been many mishaps or, Hillary suicides.
Mysterious deaths all of a sudden, falling down staircases, car crash, suicide. I mean, it's disgusting. The list goes on of doctors who have come out and then all of a sudden we don't hear from them again or they have a mysterious death. And that's the thing. You wanted to come. I wanted to get you on Skype tonight or video, but you for your privacy and preservation, you wanted to come on more anonymously, and that's totally fine. And I get that. That this is how serious it is. This is how it's not a joke, guys. I mean, they will go after doctors who tell the truth. They will go after whistleblowers who tell the truth. They are ruthless.
Taba.
And you could get your children taken away now. Now, it's if you don't have your children wear masks, or if you even don't wear a mask, then you can lose custody of your own children. How's that for living in a free country? How's that for living in America? Absolutely disgusting, despicable, and I'd love to hear your comments on it. 877-7.
The swab of a person with COVID-19 will contain a mixture of human cells, virus particles, and other microbes.
So did you hear that? It will contain a mixture of human cells, virus particles, and other microbes, which could mean bacteria or fungi or other microbes. Okay, so it's not a clean sample. And if we were testing for human DNA or RNA, we could find it because there are human cells in there and also fragments of human cells, such as apoptotic bodies or exosomes, or sometimes there's even free human DNA circulating in some of our fluids. So this is not a pure sample, and it certainly contains human genetic material from the beginning. So if we test for it, we could find it. One of the primer sequences in the PCR test, according to the Pasteur Institute protocol, is an exact match for a sequence in our own human DNA on chromosome 8.
There's not enough viral RNA to detect directly in the patient's sample, so a process called reverse transcription polymerase chain reaction, RT-PCR, amplifies many copies of a segment of the N gene.
So what they're saying is that there's a tiny, tiny amount of the RNA that we're looking for in this sample that's really messy and contains a lot of stuff. So in order to be able to detect it at such tiny, tiny amounts, they have to amplify it or make multiple copies. And that's really what the PCR test does.
Short, single-stranded pieces of DNA called primers recognize unique RNA sequences within the viral genome that bracket the target region of the N gene. After the first primer binds, an enzyme called reverse transcriptase extends, synthesizes, a single-stranded DNA copy of the viral RNA.
Okay, so I want to stop here because this really shows the important part that we need to pay attention to. That you see in the bottom right hand, there's this short primer, right? So that's the only thing that we have identified in advance, like we created the primer. We could make a primer for any sequence, for any organism. And then when we put that in this reaction, basically, we're looking for a piece of genetic material from some organism that matches it, is the complement, okay? Because when these two strands go together, they have a complementarity. It's like a plus and a minus that attract each other. And it's G's and C's and A's and T's, okay? So this is going to look for a specific sequence in the sample that we're trying to find. And what the long strand that you saw in this video is, that's the sequence that could be from another organism that we're identifying. Now, since the primer at least one of the primers that we have been talking about is an exact match for a sequence in chromosome 8, then it could identify a piece of a transcript from chromosome 8 rather than some genetic material from another organism. In other words, it can detect our own DNA.